Hi guys, today we're going to be talking about continuous functions and one method of analyzing them. The first thing we're going to talk about is increasing, decreasing, and constant. Um, you've seen that this is increasing, this is decreasing, and this is constant. But there are technical definitions, and let's read through one of them. F of x is increasing between where x is between a and b if for all x coordinates that are between a and b, the smaller x coordinate gives the smaller y coordinate. So we have, if here's our x1 and here's our x2, so the x1 has to be smaller than x2, then the y coordinate, this y coordinate, will be smaller than this y coordinate. That's what it means to be increasing. So how do we tell whether things are increasing, decreasing, or constant? Um, it's pretty easy to see visually. Um, you see that here, left of -2, things are going down, so we say it's decreasing. And I'm going to use interval notation. It's decreasing on the interval from -infinity to -2. Then the next place that it changes is at this point. Over here, we have the y coordinates remaining at 4, so it's constant on the interval between -2 and +1. Then, until it reaches this this maximum point, we have it increasing. So that's between 1 and 3. We always describe it as in terms of the x coordinate. And then lastly, decreasing because it's going down and to the right on 3 to infinity. Some other words that you already know. Maximum is the highest value, and this is talking about y coordinates. The minimum is lowest value, or usually y coordinates. And extremum. A maximum is an extremum, a minimum is an extremum. When you don't know which one you're talking about, you just call it an extremum. Some phrases that you might not have heard in this context before. So, global. A global maximum is it's the across the whole function. Whereas a local or relative maximum or minimum is just near the point. What I mean by that is here, if we have something like this, this is a local maximum because the function right here, the y coordinate is bigger here than it is here or here. The points around it are smaller, so it is a local maximum. But it's not a global maximum because over here we have a point that has a higher y coordinate. So we can refer to, is it a global maximum? No, it's not a global maximum because there's another point. But is it a local or relative maximum? Yes, it is because it's the highest point in that area. So let's identify the different local and global extrema, so minima, and maxima. So let's see, where do things turn around? This point, well, there's a point above it and a point below it. We don't care about that. Here is a minimum and minimum, and it's also a global minimum because all of the y coordinates are bigger than 1. Here, there's some points above it, some points below it, so nothing. Here, this is a local maximum because, for example, this point is above it. This is a local minimum. I'm having trouble spelling minimum. This looks like it might be a global global maximum, but then it's easy to forget that over here that it goes higher. Actually, this function, if this function continues the way it looks like it does, this function doesn't have any global maximum because it keeps getting bigger and bigger. You can think of linear functions this way. Linear functions just keep getting bigger and bigger, and they don't have a maximum. So this is a local maximum. There is no global maximum. And then here there's some points getting lower. So this is how we can identify extrema points, the highest points. You can think of these as the hills, and a global minimum is the lowest point out of all of them, not just locally low. Thanks.